Right guys, now we know how many types of problems can be framed using this formula that sin squared plus cos squared is 1. Let's go with the next formula in trigonometry. We know that is 1 plus tan squared theta is equal to secant squared theta. Now how many types of questions can they frame out of this? Alright, so how they work basically is they separate tan squared. What is tan squared theta here? It is secant squared theta minus 1. Yes. Then what is tan theta? Tan theta is root of secant squared theta minus 1. Yes. Alright, so what is theta again? Theta is tan inverse of root of secant squared theta minus 1. Okay, see, this is how we can separate theta in one case. Now if my question is, let's say y is equal to tan inverse of let's say we have root of x squared minus 1. Right, look at this, x squared minus 1. Who is x then? According to this formula, when we separate theta, if at all I have tan inverse of secant squared minus 1, alright, so then I'll get what? This guy would be actually tan squared theta, and tan will get cancelled. So here, it simply says that I need to take x as secant theta. As in this case, if we had a sign outside and there's 1 minus x squared, and this is x squared minus 1, there's a lot of difference, alright? So if there's sign 1 minus x squared, or cos inverse 1 minus x squared, it's all about this formula. When you have tan inverse and this x squared minus 1, so it has to be about this formula, correct? Keep that in mind, and remember that there is always a relation between sine and cos. In this case, the relation between tan and secant. We know another formula, a relation between cot and cosecant. We'll come to that later. Now, if at all my question was asked like this, differentiate y is equal to tan inverse of root of x squared minus 1. So we need to understand the relation. Sine and cos is related, tan and secant is related. So I can see that if tan inverse is outside, if I can take x as secant theta, see what happens. So y is equal to tan inverse of root of secant squared theta minus 1. And I know that secant squared theta minus 1 is what? It is tan theta, tan squared theta basically. From which formula? From here. See, look at this, secant squared minus 1 is tan squared. So that becomes tan squared. So I can write tan inverse of root and square will go, I'll give you tan theta itself, and see what happens. Tan is out and get theta. Now who's theta? Who's theta? Come back to this. Theta is from this guy. Can I put secant on the other side? Yes, theta would become, let's say theta is nothing but secant inverse of x. Yes. So y is equal to secant inverse of x. Can I differentiate this guy? Yep. So dy by dx now would be 1 by root of x into root 1 by x into root of x squared minus 1. This is a simple differentiation which we know from the first 23 formulas we knew. Alright. So what's happening in substitution is, from the first formula we had 4 types. In the second formula, the first type we learned was this. It looks like tan inverse of x squared minus 1. Alright. Can you find out anything else, any other type we can ask you? Yes. Let's say, if my question is y is equal to tan inverse of root of any function, let's say any function squared minus 1. So this guy is log x. How can I solve this guy? If it is x, then x becomes secant theta, just because I need secant squared minus 1, that is tan squared, and I can cancel tan and tan. The same case, if there is log, whatever is inside, I'll take that thing as secant theta. That's it. So what happens to my question? Y is equal to tan inverse of root of secant squared theta minus 1. That looks like tan inverse of root of, what is secant squared now? Secant squared minus 1 is tan squared theta. So can I cancel square and the root? Yes, that becomes tan inverse of tan theta. I cancel this guys, and what do you get? You simply get y is equal to theta. Now who's theta? Theta you always get from your substitution. So can I put the secant on the other side? Yes. So if I put secant on the other side, I'll get theta would be secant inverse of log x. Correct? Yeah, see, look at this. I'm just putting secant on the other side. I can write theta is then equal to what? Secant inverse of log x. Yeah, that's what I have. Now, how do you differentiate this? You may have a chain here, right? So whenever I have to differentiate secant theta, what was the answer? The answer is secant inverse of x is nothing but 1 by x into root of x squared minus 1. So if there's x comes here, x comes here. If there's a log x inside, I'll get what? 1 by log x into root of log x the whole squared minus 1 into differentiation of log x is what you have. So you differentiate this guy log x as 1 by x in the next step. So we understand from this formula 1 plus tan squared is equal to secant squared x. We can make a general basic formula where x squared is there. I take x squared as secant theta. If not x squared, they can ask you any function. So now you can replace this log x with any other function, anything you want. Alright, then you need to take that particular function as what? Secant theta. So let's see. If I'm not taking log x, I'm taking something else. Let's say I'm taking sine x here. So what happens? So whatever has to come here should become what? Sine x should become secant theta. That's it. So what happens to my theta? From here, theta is what? Put secant on the other side. Theta is secant inverse of sine x. That's it. So I don't have to worry about this guy because I took sine x as secant theta. I get secant squared minus 1 tan squared. This goes, everything remains same till here. Now, who was theta? Theta is secant inverse of sine x. So instead of log x, I have sine x. That's it. Nothing changes in the whole format. So I get sine x here. Correct? And I will be differentiating sine x here. That's it. Very simple. That's your answer. Correct. Now let us work on the other type. Okay, I could separate tan inverse outside. Is there a possibility I can separate secant inverse also? We'll see. This is done, right? Okay, let's talk about the same problem from here. If I'm not worrying with tan, I'm just worrying with secant. So I can just write the other way around. Secant squared theta is 1 plus tan squared theta. Then who is secant theta? That is root of 1 plus tan squared theta. And theta is secant inverse of root of 1 plus tan squared x, or tan squared theta. See, I'm separating theta here. But here, this case is secant inverse. This was tan inverse, right? So here, if my question now would look like y is equal to secant inverse root of 1 plus x squared. See, there's a difference, right? See, if it is 1 minus x squared, I need to only take sine or cos, sine inverse or cos inverse, right? So if it is 1 plus, it would be secant inverse. Or in the next problem, in the next formula, we'll see it can be cosecant inverse also. But so far, if it is a plus, it has to be secant. Why? Because 1 plus tan squared is what I'm looking for, substitution part. So let us do a problem on this and see. You can understand a more general formula and one function also. Right, so if at all my question is y is equal to secant inverse of root of 1 plus x squared, my whole intention is to make this whole thing look like secant. That's it. So that I can cancel out this secant with the secant which I get. How can I make this guy secant? I need to use trigonometry, so I'm taking x as tan theta. Yes. Why am I doing it? Just because I know that 1 plus tan squared is secant squared. Right? Now, see what happens. So y is equal to secant inverse of root of 1 plus tan squared theta. Yes, that becomes secant inverse root of, I can write secant squared theta. Square and the root is gone. So I get secant inverse of secant theta. So this is out. So y is equal to theta is what you have. Now who's theta? Theta is what you substituted, right? So I can write tan on this side. So from here theta would be tan inverse of x. Yes. Can I put it here? So y is equal to tan inverse of x. Differentiate this guy. dy by dx would be 1 by 1 plus x squared. Okay, this is what you have. Very simple. Similarly, let's say they would not give you x now, they give you another function, and how will you do that? All right, so let's say I have y is equal to secant inverse of root of any function 1 plus some function whole squared. So this time let's take cot x. All right, I'm just taking some function, any function you can take e power x, log x, any function. All right, if it is cot x, now what happens? Yeah, I need to take this guy to be tan all the time, because this has to be 1 plus tan squared only. 1 plus tan squared because I want the whole thing to become secant. I want this whole thing to become secant only. So I'll take cot x as tan theta. So what happens to my problem? That is secant inverse of root of 1 plus tan theta the whole squared. Yes, so cot x was replaced by tan theta. So what happens to this? That is secant inverse of root of 1 plus tan squared is secant squared theta. Square and the root is gone. I'll get secant inverse of secant theta. I can cancel these guys. Alright, so what's left out is y is equal to theta. Now who's theta back again? Go back to your substitution, find theta from there. So if this was theta, then can I put tan on the other side? Yes, theta becomes tan inverse of cot x. So can I put here? So y is equal to tan inverse of cot x. Yes. Now differentiate. Dy by dx would be what? 1 by 1 plus cot x the whole squared. Okay, instead of x I have cot, so I'll write cot into differentiation of cot x. So next step, differentiate cot x is what? I know that 1 by 1 plus cot x the whole squared into differentiate cot x is cosecant squared x with a negative sign. That's all about it. So now we understand there are 4 types or 4 general formats they can ask based on this one formula. Right? In this one formula we learned 1, 2, 3, 4. So with the next formula, let's say it was 1 plus tan squared theta is equal to secant squared theta. How can they ask frame questions? The first question is based on tan inverse. So I can write y is equal to tan inverse of root of x squared minus 1. This can be one form. Alright, so second guy, y is equal to tan inverse of root of any function squared minus 1, or y is equal to secant inverse of root of 1 plus x squared, this one, alright, this guy. Or it can be fourth, y is equal to secant inverse of root of 1 plus any function the whole squared, the last guy. So there can be 4 typical problems they can ask you. They can fill anything in the function here, anything that comes. So whatever comes here I will take it as secant theta, and whatever comes here I'll take it as tan theta. Why? Because tan inverse comes, the substitution has to be secant. Secant inverse comes, substitution has to be tan. That's all. So we understand these 4 guys. Now we'll go to the next trigonometric formula and see how they can make problems based on substitution. Alright.